Thank you for coming to this talk among all the other talks. Just important Go is a library that I have created for specification first programming against OpenAPI. But I will start by saying that most libraries are not worth learning. And this, unfortunately, includes JING. So I'm not going to teach you JING. Why do I say that? I would even generalize that to most tools are not worth learning. Imagine like your favorite app that you pull it up and then you need to study an instruction manual to, I don't know, order food or play a song, book a ride or whatnot. It should just work, right? So shouldn't need upfront investment. But there are things that are worth learning, but even among those, most of them should not require upfront learning. I think like collections library would be a good example. You can just start using it, experiment with the API, but then it pays off if you know some concepts behind it, like hash tables or binary trees, but you not need to know that up front, only as and when needed. Okay, so JING is a library, but I also like to see it as a collection of principles for design of this kind of boring libraries. Let's start with discoverability. So I'm here in my IDE and discover through like what's already at my fingertips. That would be in Scala for me, things like type the dot and see what the IDE suggests. Or I know the type of something, look in the companion object what it offers. Let's try to pattern match and see if I can get an exhaustive pattern match. Or quickly look at Scala doc and see what the compiler has to say. And only after this would I say I would reach to search or an LLM assistant or Stack Overflow or external documentation, because those things for me kind of disrupt the flow, but this is at my fingertips. Then guidance. Ideally, a well-designed library would guide me through the domain that's new to me. Library would offer a ramp, but no hard limit on what I can achieve. Reasonable amount of safety, because if I start knowing nothing about the domain, how am I not going to shoot myself in the foot? So reasonable guardrails. Hide unnecessary details, in other words, the right level of abstraction. For example, don't leak your underlying JSON library or throw Clicely in user's face when you want to write a web server. And ideally, zero setup, if possible. That means just import your dependency and explore from there. Just import and go. Okay, I have good news in Scala. We're doing quite good with respect to these principles already. I think you would agree. But I think we can do better. Ideally, Scala would be the only thing that we need to know upfront and discover the rest through the libraries. Okay, back to JING, the library. So it's for OpenAPI. What's OpenAPI? It's a specification language for HTTP APIs. And I'm not going to say more about that because we'll discover that through more through the library. When I say against specification, that means the specification comes first and then my code. So let's review what the state of the art for specification first APIs looks like. You start with a document, that's your specification, then generate some code from that, which gives you a set of Scala files, and then take those and import those into your project and go from there. There's this codegen part that requires a sort of upfront investment because you need to set it up in your SBT or other build tool, so you need to study the documentation of the tool to set it up. Let's look at JING. You also start with a specification and import it directly into your project. Now the import should be in quotes, but it's basically the same experience as just importing, as if importing OpenAPI spec directly into your Scala code. Okay, so enough of intro, and I'm going to try to give you a raw experience, what it could look like from nothing. So I have set up here just a hello world with one dependency on the JING library, nothing else. It should run, gives us hello world, good. So there's one piece of information that you need to take, one line from documentation, and that's something like this. This is the import of just import and go. Now you paste a URL of your specification. I have a note about that here. You could directly paste something from the web, but since I don't have Wi-Fi running, you can also use a local file. And this now, in compile time, generates some code for you. Since the compilation will run over and over, let me just quickly move this to a separate file so that it's not regenerated all the time. I actually have it ready here already. Okay, so let's have a look what's in that one value that we imported. As I said, let's try typing a dot. So what's in it? There's endpoint list, paths, schemas. For some reason, it's here twice. Paths is like the part of the URL behind the hostname. scaladays.org/schedule. /schedule is the path. So let's have a look there. Okay, let's keep typing dots. Oh, there are some paths there. So let's pick something. Pet/find by status. Why not? Type the dot. Okay, I wish these were like deprioritized, but get is an HTTP method. So let's try that. It's a get endpoint. Let's type the dot. Method, well, that's just the get. We're not interested in schema now. We want to interpret this endpoint, actually get to running something. So interpret looks like a good choice. The documentation is off screen for that, but it says here a common interpretation would be a client endpoint or a server endpoint, and then there's an example. So it guides us what to do. Let me listen to that example, and then I can interpret it as a client endpoint. So it says import this thing and interpret as. Yeah, metals is kind of work in progress. I do report a lot of these problems to the metals team, so it will get better. Let's go again. Interpret as client and point. All right. Yeah, we want to get to running it. So let's see. For some reason. Yeah, okay, good. It says params, and the documentation used to supply parameters to this endpoint. So let's try that. let me keep typing the dot. Yes, because I have increased the font so much, the idea is somewhat garbled. But there's a few methods here. They all let us apply parameters, and I just want to find out which one is kind of the, will eventually have the best ergonomy, but this one is interesting. This is a named tuple, if you recognize that. So let's try using that. So that's apply. Now, in the future, hopefully this will be fixed as well. It gives you the actual type that it needs, but in the meantime, let's copy it from here. So it's a named tuple of this type. Okay, we need to import a bunch of stuff. Let's do that. Let's import actually everything. Sorry. From here. Good. So parameters we are providing as a named tuple of this type. It's a union type, so we could just provide none. Let's do that for starters. And we know we don't need to spell out apply. Good. And now we might be able to actually run the thing, but we need to provide the server URL. This is a public API that runs on the Swagger server, but since I don't have Wi-Fi, I will use my local server, by the way, also implemented using JING, and do that. And there is a compilation error. So another thing that I mentioned, like what's at my fingertips, is compiler errors. So this says no given client instance, and to use the default client, let's import this, but it's in a different library. So let's try to follow the advice. Library. Okay, I now need to re-import the build, to give it a few seconds. On purpose, I did not have this set up so that I don't have a Polish experience, just flashed you the final code. Okay, and now save this one. It now compiles. All right, let's try running it. And it works. It gives us something. Okay, so some sort of result, and we can. Okay, we want to do more than print lines, so I just now want to show you that with this we can dig deeper. Arbitrarily deep into the structure. So let's see. What's on result? There's like assert success. That does look like a happy path. So if it's not success, let's just throw exception. Oops. What's next? Oh, assert status. So first one was kind of like if it failed, that would be network error, but now the HTTP response. So, and it could be 200, you would know that it's success, or 400, or default. Let's choose the happy path. Assert status 200. Okay. What's next?
Now I again
wish these were deprioritized, I actually have opened the ticket for metals for this. What I want is assert. Okay, let's back up a little bit. Let's look at what the type of this thing is. It's a value of a discriminated union. Discriminated union is like either but for any number of cases. So it's either JSON or XML. Ideally, we wouldn't care, but this is an OpenAPI specific that you could return JSON with some data and XML with other data, other schema. So they could potentially be different types, but they are the same type. Okay, so let's see what we have here. And we also can assert the case and tell it that it's JSON. Let's say. So all of these are happy path, right? Okay, what's the type now? Oh, it's value of an array of pets, where pet comes from the schema that we imported. So what can we do with the value of an array? Thank you. Yes, it should be X. We can get a Scala array. We can maybe iterate over Scala array. So get an individual pet, and I don't know, print line the pet. Pet is a value of a pet, so let's try to run it. Okay, and it gives us one line per pet. Looks like JSON. We can dig in more. Yeah, what could we do with the pet? We could try the dot, but since pet comes from this schema, the library does not know about it. But another thing I mentioned is look in the companion object. So let's look in the companion object of the type pet. There's a bunch of methods. Does anything take value of pet? Yeah, there's like 3 of them, 2 named tuple or unapplied. That's for pattern matching. So let's try that. Let's rewrite this to a pattern match. We don't know yet what it will return. So let's see. So I can pattern match on a pet and get back a named tuple again, which has some fields like ID, name, and so on. So yeah, let's just get something out. Let's say name and status. So you might know that to pattern match on a named tuple, you write out the fields that you want and assign them to variables. And now we can print the name and status. Let's run. And yes, we got formatted output. The point is you can destructure as much as you want. Well, one more thing I'm going to say. I use this happy path operators, but when you need to get something to production, you actually have to handle errors. So let's show you can exhaustively handle all the cases. So let's try to do that. Let's say for the media type here. This value that's a discriminated union has a discriminator. and its type is, in this case, it's either JSON or XML. So to handle it exhaustively, we could do an exhaustive pattern match. I wish the IDE would expand this automatically for a union of singletons, but does not currently. So yeah, we can get an exhaustive pattern match, and now we can do the assertion will now be safe because we checked the value. And coincidentally, in this API specification, both JSON and XML have the same structure, so yeah, an array of pets. Anyways, I find this somewhat ugly to like check the value and then do something unsafe. So I'll just say that there is yet a different way that avoids these unsafe operations altogether, and that looks something like this. Switch, and now you, I'm speeding up through this. It forces you to only specify JSON because that's the first case. And then you provide the handler for JSON. We will not do any transformation here. The next case will be, it suggests you XML because that's the next case. And then again, handle that case. And then we need to type this incantation, which you would find through the IDE again. And if we assign this to a variable, we'll see it has the right type, an array of pets. And if we, so by the way, so we see a lot of strings here, but strings are types too. So if I make a typo in there, it does not compile, and the compiler gives me, oh, it's not the thing that I expected. If I forget to mention a case, the compiler also yells at me. Maybe this one could use a better error message, but it does not compile. So yeah, there are there's like a lot of guardrails. Yeah, I could go on to show you like posting a post request with the body where we would specify the structure. Again, we are named tuples. I could show you the server code, but I will end the demo here because I want to get to the remaining of the slides. So let's continue. Yeah, I showed you exhaustive error handling. I showed you some features of type safety. Servers are supported. This one I haven't shown you, but JING is not feature complete with respect to OpenAPI, but wherever there's something unsupported, you can still use all the rest. So if there's some schema that's not yet supported and it's only in one endpoint, only in one media type, but you don't use that, you can still use the rest. It's not like with some codegen libraries, they just fail at codegen time because they encountered something that they don't support yet. Let's check what we saw against the principles that I showed you in the beginning. So discoverability, yeah, I would say yes. We were typing dot a lot. We looked in the companion. We looked at error messages. Didn't need to search any external documentation. Guidance, yeah, we didn't need to know anything about OpenAPI. We also didn't learn much yet about OpenAPI, but we didn't need to. It definitely gives us a ramp. Currently, there's a ceiling because of the feature completeness, right? So I'm not going to say it has no ceiling because, for example, doesn't let you authenticate yet, or yeah, it's not feature complete. Safety, yeah, there's a lot of type safety built in. We didn't see any JSON serialization stuff or even HTTP stuff. So yeah, I say it hides unnecessary details. And was zero setup. We just imported a library and then imported the spec. Okay, you could object that these principles are applicable only when something is well understood, like OpenAPI. Like there's not, you are not breaking new ground. But to that, I would reply, at the stage when you are writing a library, it's assumed you have a good understanding of the domain. Okay, I want to give you, I want to justify some of the design choices, why what you saw looks like it does. So first of all, when we imported the specification, its type is a big structural type. This is what it looks like. It's much bigger in reality. So what's interesting here, there are no new classes generated, as in classical codegen. All the types that we see here are either already exist in the library or are abstract, but then in the implementation are just type aliases, or they are structural refinements of existing types. So why is that? And this comes from the limitation of macros in Scala 3, which is that they do not allow you to introduce new definition. So this definition, val API, exists in my source code. I cannot add anything else that would be visible to the to type checking of the rest of the program. So this, there's a question? Go ahead.
Thomas, have you tried it without by defining the whole class path available and then using just Scala C with a macro that will generate your class?
Sorry, say it again. Because
if you use just Scala C by itself without using JING, sometimes you can bypass that limitation.
Okay, I did not know about that, that you could bypass it. Yeah, stop by afterwards and tell me about that. So anyways, I felt like I don't know any better way to do this, so I didn't really have a choice. Feel free to propose ideas. Next, you did not really need to understand it, but pet is underneath was generated as a type alias for these composed types. I guess it's kind of self-explanatory. It's an object type with these fields. Some of them are optional, some of them are required, but you could ask why not instead do something like this using standard Scala types like named tuple. And we actually saw a bunch of named tuples already, and use option for optional parameters, use Scala union of singletons for enums, or string for strings instead of something custom. The reason is this is not quite faithful, right? Scala doesn't have a notion of an optional field. So if you see ID that has type option, so is it optional field or is it a required field which is in fact serialized as something like, let's say, nullable? You wouldn't really know from this, whereas you know here. Or enums, a union of singletons does not quite capture everything because in OpenAPI, the enums are different. They have some base type, like string, and then an enumeration of values from the type. So that's lost here. Or name tuples are a nice way to express these object types, but then we don't have an analog for the sum types, the n-ary either. So tuples are n-ary, but either is not n-ary, and where we saw the discriminated union, that was an analog of this object type, but as a sum type. So that's why, and also I find it, and you could object to this, just use different types for the domain than the domain being OpenAPI here, than Scala types, just to know what lives in what universe. And I'll get a little bit more to this in the next slide, but these generated tuples don't make good GADT indices. But anyways, I chose this. This could have looked differently. This would be workable, especially since with the value, if you carry the schema, there would be no ambiguity with the option, but yeah, this was a choice. And then you might have noticed when we had a value, it had a type value. It was like value of pet instead of pet, just pet. So why is that? So one reason is to reinforce the separation of domain types versus Scala types. Let's make these domain types uninhabited in the Scala universe. So if pet is a type alias for object, this object is not inhabited in Scala, and then the value acts as a bridge between these two universes. But also, this extra wrapper type gives me freedom to change the implementation. For example, use a match type, which would match on object, and for object, it would create a name tuple, let's say, to bridge with Scala, and keep these domain types as well-behaved GADT indices. What do I mean by that? We didn't work with a schema, but whenever we see a schema of type pet, pet is an object. So whenever we see a schema of object, it unambiguously means it's a certain case of the schema ADT, which if this object was a match type, yeah, good luck with that. You could possibly make it work with some unsafe casts in the implementation, but I also like to be safe, not use as instance of in the implementation. Anyway, so this was a genuine choice as well. This could have looked otherwise. Okay, let's get to some future directions. I mentioned that it's not feature complete, so yeah, it needs to be made feature complete enough to be usable in production. For example, authentication, as I mentioned, is not supported. There's much more features of OpenAPI. The goal is not to cover all of OpenAPI, but enough for it to be usable. There's a lot of intermediate object allocations. I'll not go deep into that, but let's say an object with n fields has an overhead of extra n allocations because of the way it's represented. It could be made flatter with, let's say, name tuples under the hood. Avoid first parsing to JSON and then to values. That is, do something like JSONiter does, but parsing into values, not the Scala classes. So we have these values. When we get values from JING, those are wrapped in values. We could transform them to Scala classes. We can do that today because we can deconstruct them and construct our domain model in Scala, but that's done manually, and we could implement something like chimney or duct tape, but transforming from values, not from Scala classes. We could generalize this to declarative transformation and then possibly fuse parsing with conversion to domain model. For that, we would need something like a declarative description of transformation that does not include Scala functions inside, because Scala functions will produce Scala objects that we want to avoid, the intermediate ones. If only there was a way to do that. But yeah, there is, and if you're interested, I invite you to watch my talk from previous Scala Days about that. And yeah, there's more, but this will keep me entertained for a while. Okay, getting to the close. So takeaways. So I started this exploration with a question whether we could have spec-first APIs without separate codegen paths, and the answer is, oh yeah, hell yeah, we can today. And then I want to instill this vision for library design where Scala is all you need to know up front, and the libraries can guide you through the rest. Just import and go. And this is not my last slide. My last slide is a call to action. So this was for, what we saw was for OpenAPI, but there are many more specification languages. So I would be very happy if I inspired at least one of you to do JING for, let's say, Avro or gRPC or Smithy or GraphQL, you name it. And with that, thank you.
I was going to ask if you have thought about protobuf, but turns out yes, you have. Any questions? I think we have time for one or two questions.
Thank you for a really insightful talk. I think there's something in there, in the ideas behind JING, that may deserve a more explicit mention. Like, we should talk more about these principles that you have kind of revealed or presented as the most important ones for library exploration. And have you considered writing some kind of manifesto, like just import and go for the ecosystem of libraries?
Have I considered writing a manifesto? Well, so this talk was a manifesto, but why not? Yeah, well, let's write the principles, yeah, JING principles for library design, and yeah.
Yeah, unfortunately, jingoism is already taken as a...
Yeah, so I have a question comparing this to the classic approach of code generation. So with code generation, well, you can generate the code in one step and compile later on. Whereas now, if I understand correctly, for example, in the URL case, you're pulling in as you compile. And as you mentioned, without Wi-Fi, you can't compile anymore. So right. I'm wondering, are there any tricks you can use to essentially cache this so that you don't fall into this?
So the trick is to do this, have a local copy. This is, by the way, relative to the source file, right? So it lives right next to it. That's the trick, have a local copy, right? And then I don't know how would you cache it, but the incremental compiler caches this file, right? You need to cache it at compile time, so you need to plug into the build infrastructure and have a cache at that level. I think like incremental compiler is good enough, but then if you really want to be safe offline, yeah, make a copy. You know, this online version could also change without you knowing, so yeah, so start with this for exploration, and then make a local copy.
All right. I think we are out of time, so let's thank the speaker again.